Good morning, afternoon, evening, wherever you are on this globe, and welcome everybody to our second series of oil and gas related webinars. Today we'll have a great speaker in Daniel Persson on the topic of heartbeat and the practical use cases for it in oil and gas. Daniel is our process and portfolio manager for our corporate innovation process, working from our corporate marketing department in Switzerland. He's one of the founding fathers of heartbeat technology from a development perspective, so he's a great one to have online today. This webinar will last roughly about 45 minutes, 30 minutes presentations, and 10-15 minutes questions and answers. My name is Rob Vermeulen, and I'm the Global Industry Manager for Oil and Gas at Endress Hauser, located in Greenwood, close to Indianapolis, the place for the Indy 500 in Indiana in America. Before we start, we'd like to have a safety moment, as is a custom at Endress Hauser and at Oil and Gas. And today we like to focus on the worldwide pandemic on the corona crisis. Please wash your hands on a regular basis. Keep at least 6 feet and 1.5 meter or 1.5 meter distance from other people. Wear a mask when in public. Avoid coughing in public, and please use your national tracking app when available, so you can be warned in case of need. Small introduction of Endress Hauser. Daniel, maybe you can change the slide. Yes. Endress Hauser is a global company, over 14,000 people worldwide, and we have a revenue of around 2.6 billion euro or US dollars. Our headquarters is in Basel, Switzerland, and our core business is to develop, produce, and service process and laboratory instrumentation to measure quality and quantity parameters. We also develop integrated instrumentation solutions and services around them. We own and license over 8,000 patents. Well, this is a very short introduction of Endress Hauser. And with this, I would like to hand over to Daniel, so he can introduce himself and the topic of today a little bit more. Daniel, Persson doesn't sound very Swiss, and you have a funny accent, I must say. You need to explain this to us.
You saying being Dutch. Thank you very much, Rob. Nice to have this presentation from you. For you, it's as Rob says, my name is Daniel. My accent is Swedish, but I have been in Switzerland for quite some time now. Most of the time, more than 10 years, I've been working for Endress Hauser. Yeah, you heard my present responsibilities with heartbeat technology, safety aspects, etc. Before, I was also a product manager for Coriolis flow meters for many years. The talk that I would like to have with you today is to talk about this word cloud. We know that when we try to optimize our operations, we have a lot of things to consider. Safety, reliability, availability. We want to be efficient. We, in the end of the day, of course, want to be safe. That's our highest priority, but we also need to make sure that we have very good operations that are economically viable. And this is where we at Endress Hauser work with heartbeat technology. And this presentation, if I can show you 1 or 2 things today that you feel, wow, this is really something that I can profit from in my daily operations, then I'm really happy. I want to show you how do we at Endress Hauser think when we design instrumentation with heartbeat technology, so you understand the design philosophy of it. But the second point is much more important. That is, how can you profit from it, and in which way can you profit from it? So if we now take some bullets about the design philosophy. Safety, number 1. That is just the highest priority. But of course, we should not forget that the reason why you buy a device in the first place is that you want to have a functionality, and that this should of course also be excellent. It has to be reliable, because no one wants to work with things that are not reliable. The availability in the operation has to be high, and we also want to have a user-friendly, intuitive interface that just bring efficiency gains. Summarizing everything, 2 words: safety and money. That is what it comes down to. And this is our Northern Star, our guidance when we design devices with heartbeat technology. Now going into a little bit more in detail, we have three pillars. We call them heartbeat diagnostics. Here we talk all about reliability and safety in operations, and we will go into detail what we mean with this in this presentation. Second topic is heartbeat verification. There it's about availability and productivity gains. Many times you can actually use this verification technology in coexistence with calibration or proving efforts. So we will discuss how you can use verification in hopefully a very optimal way later on in this presentation. And we will round off with heartbeat monitoring, which is also then giving you more insight to your process, be it how is my process feeling at the moment? Do I have any quality issues, possible disturbances in the process? Or could it be that actually I am wearing down my instrumentation, or that I have foam creation or buildup, that you can see that over time, enabling you to do maintenance activities in a timely and optimally planned manner. So that's the overview. Will take some 20-25 minutes, and then, as Rob said, we will also take the questions after that. This is a graphical way to see heartbeat technology, basically what I already told you. So now let's start with diagnostics. The promise we give with diagnostics, okay, it is device diagnostics, no big surprise, but it should bring increased plant availability and safe processes. Now, let's dig into that. Why is that so? First of all, the devices with heartbeat has a very high diagnostic coverage. With this, in practical terms, means that if something goes wrong in the device is extremely likely to tell you so. That the risk that actually you have a problem in the device without the device telling you is extremely low. This, of course, gives you reliability and confidence in the device functionality. It is not only that it's telling you that it has a problem, it is also the messages that you're getting are categorized according to the NAMO recommendation number 107 with the status information and the categories connected to that. The purpose of this recommendation from the industry is that if something happens, you should know what happens and also what should you do when something happens. So no more like error code 137 and you have to look for a manual. You get direct, clear text information, what happened and what should I do next. This actually has, and this should not be underestimated, it has a very nice safety aspect to it also. Because since you get the right information in a timely manner, you will have a safety gain because you will do the right thing and there's no risk for mix-up or wrong information. This will have obvious benefits in the maintenance activities, and also it will connect to better plant availability because you will have less surprises. In Endress Hauser, we commit to design our instrumentation to the functional safety standard IEC 61508, which, without going into detail, because that would be another online seminar, it is a very structured way how to develop instrumentation. And also on top of this, as you will see later also, it is not only that we follow this development standard, we also have third parties evaluating and checking that we follow this standard. Summarizing, 24/7 health check. Yes, it's running all the time when the device is on, and it will bring you a very high level of confidence that the device is okay. If we now try to put this into context with older instrumentation, or not old, probably you have these instrumentations installed in your plants, quite many of them. Take, in our case at Endress Hauser, maybe the Coriolis meter Promas 83F. Without going into detail here and talking about functional safety terms, etc., The red part of this chart is the failures where the device will not mention that something is wrong. What we did with heartbeat technology is that we did our utmost to minimize this part. Obvious gains. With this said, don't worry, your installed base is solid. It is very good values. These also, the probability that this will happen, if you see it from a statistical point of view, is really, really, really low. But it got even better with heartbeat. So the diagnostic coverage of all the instrumentation was good, but it got then even better with heartbeat. If we look at verification, also there, state of the art that time was to come with external tooling to do the verification. Also very good, works still today very nicely. But with heartbeat, we did it more practical for the user, that we built in this verification capabilities in the device, and we will talk about the benefit that brings soon. Monitoring capabilities, to be honest, it was maybe not that much and not so easy to use in the old meters. But here we took a totally new approach, is that all these sensor specific signals that are available from our devices, we try to make them as visible and easy for you to track as possible. So you can use these signals to see if something is going on in the process. For instance, corrosion, buildup, foam detection, etc. These signals, we should always remember that any measurement device works on physical principles. And even though a flow meter will give you maybe a mass or a volume flow, of course, in the background, you have a lot of signals, amplitudes, frequencies, damping values, and so on, that are in the background. And these have now been made available. And when the device changes its mechanical properties, or when the process influences the device, many times you can get quite smart information out from these signals, since they are reacting to a change in the process or on the meter. So when we say best diagnostic coverage, how did we come there? How did we do this reduction? Very simply said, in the old devices, we had state of the art at that time, which for Coriolis was that we had one frequency generator. Now for heartbeat technology, we actually have built in two of them and put the circuits in such a way that you could say that the circuits are checking each other while measuring. Same thing for mag meters. So there we have voltage references built in. So it's just summarized, because this would also be a webinar of its own. It is using smart design concepts to make sure that if something happens in the device, that it should let you know. And that is the reason why you reduce these lambda DUs, the red errors we saw on the graph. So that was diagnostics. Let's go into verification. Okay, documented verification without process interruption, increased plant availability, and reduced verification effort. Let's look into detail why we do these statements. First of all, this is now an inline verification without process interruptions. So the verification is happening inside the device itself. And many times even a measuring signal is active during, so the measurement is live during the verification. We offer a lot of different physical principles and measurement technologies at Endress Hauser, and wherever it's possible, we strive for that. For some technologies, it's just not possible to keep it live all the time, and then maybe you have hold loss value for some seconds and so on. But in the end of the day, there are very quick processes to do a verification, and you know when you trigger it, so you will have full control as a user. This verification is running all the diagnostic checks, absolutely everything it can during when activated. So it is a complete diagnostic coverage of the entire device, starting from the sensor unit all the way up to the electronics and the output. It will give you a result. Did this verification pass or did it fail? Just to keep it simple. If you want to have more details, which might especially be interesting if something failed, you can also do a verification report. And this is then easy accessible via asset management system, field care tooling. You could even do it via your telephone and so on. But maybe for some of you, it will be enough to have, is it good or not? And some want to document further. I will show you in the next slide how these reports look like. We aim here to make your life easier. That, of course, you're not only getting the verification report, it's also all the device data, the serial numbers, etc., to make your documentation and audit efforts easier. What is then really interesting, and what I also will dig into a little bit soon here, is that this verification approach, heartbeat verification, gives you a possibility maybe even to extend your proving cycles. Let's talk about this soon. What we also do for many of our technologies is that we have, as I already mentioned, we have a third party. We often work with the TUV, and they come in and look at our whole development program, and they also confirm this statement that you see up here, that it is a traceable verification method according to ISO 9001. And it's about the productivity gains and the compliance. We will exactly look at the slides that are coming now, why this is the case. So just shortly, this TÜV attestation. So this is a paper from TÜV where they state that it's traceable verification according to the ISO 9001. So the compliance is given. Now let's come to how can you use this to save in calibration or proving efforts. First of all, it depends. If your regulations internal or your legislation really say you have to calibrate maybe yearly or whatever, if it really is that strict, of course you have to do that. But as we will see, many of these standards open up for the coexistence of calibration and verification. Here is one example from the ISO 9001, where you see that a device should be calibrated or verified at specific intervals or prior to use. So there might very well be possibilities to use this coexistence of verification and calibration that I will present to you now. So both are compliant, of course. Calibration, we know it is on accredited rigs. They are traceable according to ISO 025. We do know that we put a fluid through the meter at a certain condition with a flow rate, a pressure, a temperature, and so on. What is then maybe not so nice is that we either have to build it out from the pipeline and send it to the factory, or come with a mobile rig, or maybe we have a bypass where we could do these activities. So it is some efforts, and many times it will also then be connected to a process interruption, just by nature. Then looking at verification, this has nothing to do with a calibration fluid. It is just the flow meter checking itself, is my function okay? So it's running all these tests possible and confirming. You see once again this circle graph, confirming to a very, very high level of confidence that this device is okay. It does so under operating conditions. You can keep the meter in place. You do not have to touch it. Actually, also what is modern technology is like Wi-Fi connections and so on. You could even do a verification with your mobile phone if it so allows in your operation. And when you have an EXA-approved tablet, etc., the modern technology really literally makes it possible to do a verification without even touching the device. Since you don't have to touch the device, also the risk for systematic faults reduces drastically, or actually you eliminate them more or less. Because if you don't touch the device, you do something wrong. You cannot do something wrong. We got feedback from many of our customers, and when we asked them, how often do you have issues when you build out a meter and then you install it again after calibration? How often do something happen? Many times the answer is around 2 to 4 to 5% of the times, so like 1 in 20 or something like this, that they could have an issue. And this is also nothing to underestimate, because it could be that you have a transport damage, you maybe do wrong cabling when you install it again, whatever, that you just have a human mistake. So that should also be balanced in the whole picture with verification. Some of our customers do calibration, then they do verification, they do calibration again. Some do a lot of verifications, some prefer to stay with the traditional way of calibrating. This is really up to you. With this presentation, I would like to show you that you might have the flexibility to be more agile and save money in your operations. And if your legislation and internal regulations so allow, please do so. The report, also here, of course, we have the ISO 9001 statement. The report has all the details of the device. It is not only about electrical components and so on that get checked. If we take the Coriolis meter, we have the heartbeat sensor integrity value, which shows you also the mechanical response from the entire sensor. So the measuring tubes, the drive coils, the pickup coils, that of course has a defined value from the factory. And if this changes over time, let's say that you're corroding your pipes or you have a problem with a coil or whatever, you will notice it from these values. So a stable HPSI, of course, then is a good thing. And if you see that it drifts away, you could also monitor that value. Then, of course, you might need to take action. Also here, a good contribution to safety on top of the diagnostic information. Paper trail, I think I mentioned this. Of course, a calibration certificate will be very compliant, will give you the confirmation that you need, and also the heartbeat verification report. So that should be no issue. How can you trigger a heartbeat verification? Also here, I think I mentioned it. Of course, you can walk up to the device and push the buttons and start it. You can do it via your tablet, your telephone, via field care, via your asset management system. You can also trigger from the DCS, the verification. If it's enough with you pass or fail, you will get it in all these interfaces. If you also want to take out a full verification report, you can do it via the tablet, via the field care, via your asset management system, etc. Monitoring. So the promise, predictive maintenance, plant availability again, and optimizing the processes and maintenance activities. Let's dig in. So here you have these dedicated parameters. So we could call it the secondary parameters from the device. If you buy a level device, of course, you buy it to measure level, but you can then also use these other parameters that run in the background to be smarter. It gives you opportunity to do corrective actions, or it could also be turned around. Maybe for some processes, you want to keep the process in a certain state. Okay, in your case, in your industry, in oil and gas, I guess that bubbles are mainly a nuisance. So maybe you want to detect when this happens. In some industries, maybe like life sciences, bubbles could actually be a value because you want to have a product with a little bubbles in it, or in food and beverage, in ice cream. You can also use it for quality control. But the main thing is that you will see over time if something changes. And this then gives very good process insights, and it can help you to be smarter in your maintenance activities. I selected here a level example that we will go through. It's a lot of possibilities. As I said, corrosion buildup, foam detection, etc. But let's go through this one just as an example how heartbeat monitoring can offer you value in one hopefully very relevant application for you. So we start on the left side. We have a tank. We have a radar that measures the level, and we get the signal. If the foam starts to create, the signal will decrease, and if the foam grows even more, the signal will be even weaker. If this now would continue, we would have risk of a foam overspill. We don't want that. So looking at this now in an animated way, we see that we have our signals, and with experience we can say, when I reach under this lower limit, things start to be critical. We need to do something. So when the foam now starts, the meter or the signal weakens, and now you come under the threshold, and then you can connect that to a diagnostic information and an action. You can, for instance, switch status output, maybe to start a defoaming action, to defoam with a sprinkler here. Then, of course, the foam will go away and the value will increase again, and then it will stop. So it's pretty straightforward, but everything then automatic. How do you do that? Really, like if you would have this in your plant now and you want to do that. Here we do our best to make it easy for you. If you see here, this is one interface where you can run a verification. Here you have some monitoring, foam detection, buildup detection, and in this case, you would of course click on foam detection. Then you come into a wizard that guides you through how you should set this up. It also, you don't have to read this text now. If you're curious, please download the PDF and do so. But for every step of this wizard, you will get guided. We try to provide as much insight as possible to you, so it's easy for you to set this up. And here, I just wanted to show you a practical signal, how the envelope curves could look like. So let's say in this example that we put the lower limit here at 10 decibel. We have a signal. We see that the relative echo amplitude is 27 here. It's good, so it's over. We don't have so much foam. The status signal is okay, and the diagnostics here in the bottom left is also just not giving an output. Now we have a lot of foam, so we're under the lower limit. The relative echo amplitude has gone down to 6 decibel, which is lower than the limit set, and the status signal switches. Here down we have the diagnostic information also. So now the sprinkler starts, and the foam is going away, and the signal is then coming up again. So very straightforward, just automating a potentially critical application. Yeah, we only have so much limited time today, but I hope that this part here now that I told you gave you some rough insight what heartbeat technology stands for, what we're trying to do, and more importantly, how you could profit from heartbeat technology in your operation. And as a summary slide, I like this example or this approach, how we could think about heartbeat. Let's say that you have bought 100 instruments from Endress Hauser, level, pressure, temperature, flow, analytics, and so on. Just a mix for a lot of different applications. And now you think, okay, how can we profit from these? What is the optimal benefit for us to use these? If we then start with heartbeat diagnostics, here I think the best-in-class diagnostic coverage that we have, and the reliability, and of course the technical excellence of the devices will play a value for all installation points. It does not matter if it's the most basic point that where we're measuring, or if it's a very critical measuring point. We always want the device to be safe and reliable. When it comes to heartbeat verification, here I think that we should be a little bit more selective, because just to do verification on each single measuring point would be overkill. Here we should be more selective and see when we do the verification effort, because even though it's just the push of a button and so on, it always will be a little bit effort, and we should only do that effort really where it pays off. And I think that the values here can be actually quite big, because if we can prolong a proving interval or a calibration, then of course the payback is given directly. But here we have to identify these points. Same thing with monitoring. We could monitor everything, all signals for all technologies, but to which value? We have to find out which are the measuring points where we do want to monitor extra signals. This could be driven by quality reasons, by maintenance reasons, by safety reasons, etc. And it most likely will be on the more critical points then. As you see, some points only have the diagnostics as the basic value. I think that is totally okay also, because there will be instrumentation that it's totally okay if they break, maybe unlikely that they will, but if they break, we just put in a new one. We just don't want to put the effort on that. And so how does this matrix look for you? Well, it depends, of course, on the technical capabilities of Heartbeat, but also how do you want to approach your operation and maintenance. And I think that when we sit together here and discuss, then we can really come into good discussions to see how can we optimize your Heartbeat matrix to make sure that we're doing the right effort in the right points. And with this presentation, I hope that I have made you curious. I hope that you got one or two ideas that you can profit from. And now I hand over back to you, Rob.
Yeah, well, hey, thanks again, man. It's a great presentation. I got some stuff out of it as well. Before we start the Q&A section online, just be aware that in the handout you can actually download a copy of Daniel's presentation as well. And if you have further questions after the fact, just send either myself or Daniel an email, and we'll try to get a hold of you as soon as possible. Email address you see on your screen, it's very simple, rob.vermeulen or daniel.persson@endress.com. It's not so complicated. Daniel, I got some questions. Yep. Let me see. First question, does the instrument give any advice when it's time to calibrate?
No, actually it doesn't, because that depends on which kind of needs you have. It's difficult for us to know, like because if let's say that we have the basic specification of a meter, let's say that we have a 0.1% meter. Actually, the need to calibrate might be okay if it's measuring 0.2, 0.3 or whatever. So that depends quite a lot on your needs in operations. And yeah, it's a little bit tricky for us to implement that.
Yeah. Next question. We run our installations mostly to fail and then repair. Can Heartbeat give us information when this might happen?
Yes, it can. It really can, because if you run to failure, it will be due to a reason. Because a failure will mean that you have more or less destroyed the device. So it's corroded away, it's maybe abraded away, or you have buildup that clogs the whole pipe, etc. This you can take from Heartbeat monitoring. So depending on your failure type, you can select the right signal. Just come in discussion with us, because it of course depends on which technology you're having and which kind of process, or like which kind of deteriorating process that you have. Then we can monitor that, and they will be very repetitive, the signals that you get. So let's say in case of buildup, you reach a certain buildup level, you will see this from the signal, then you clean it, then you go back to 0 because it's clean, and then it goes up, and you can just optimize your operation in this way. So a clear yes to that question.
So it's kind of a sawtooth process then. You see the buildup go down. So yep.
Yeah, and then some, like corrosion never goes back. So there it's just one-way traffic. Yeah. But there maybe you can say, okay, I'm okay if it is at this certain value, then I'm okay. But if it goes over this, it's time to replace the meter. Or you can change your process condition to maybe stop the corrosion, which maybe will be challenging, of course.
Yeah, I got 2 more questions, Daniel. This question is from Bancole. Can you confirm if all Endress Hauser devices come with heartbeat?
I can say like this: the legacy devices, the old devices, do not have heartbeat and will not have heartbeat, because the heartbeat, as you saw, is a design concept. So we're designing new instrumentation. So the installed base, some of that it's also devices that we're still selling. They will not have heartbeat, but the new devices that you see coming from Endress Hauser will basically all of them have heartbeat, because it is a design concept that we believe in, and it brings safety and reliability, etc. All the things that I talked to you about here. So it's really a commitment from Endress Hauser. So if you only look at the devices that are new on the market since some years and the future products to come, expect heartbeat.
Yeah. And then the last question. How can I get the foam data you showed in my control system?
Depends. To the colleague that sent that question, if you please could drop us a little bit of a note which control system you have and the frame conditions there, because that would be needed to answer that question in a good way. So okay. It's yeah.
Good. Well, with this, if there are no further questions, I'd like to end the webinar. Daniel, thank you again for your contribution. It was a great story, and I think very practical also with regards to the applications for oil and gas related activities and problems that we see in the field. I'd just like to make you guys aware that next week, Tuesday, and next week, Thursday, we have the next sessions on oil and gas related topics on the Endress Hauser webinar series. Same time, same location. Please look for the invites with regards to the logon data for the GoToWebinar. And if not, just send me or drop me an email and I'll send it to you as well. Daniel, any last words?
Yeah, thank you very much to the audience for the attention, and thank you, Rob, also for the moderation. It's a pleasure to present Heartbeat to you, but more important, I hope that you and your families all stay safe, and I wish you a continued nice day. Thank you very much.
Yeah, thank you very, very much. And with this, I'd like to end the webinar. Thank you.
Thank you.